Okay, so we have problem 51, I believe in section 12.6. And let's just say we got some liquid or granular solid, as the book says, that we need to pump from here up to here. So let's just think of an oil well. You got this volume of oil here with a center of mass here. The center of mass we're going to assume is at the origin. We'll set our coordinate system so the center of mass is at the origin. And we're going to pump all the way up to here. We're going to load tanker trucks, drive the stuff off. Alternatively, maybe we've got a pipeline. But whatever we do, we've got to raise all this stuff up to here. We want to know how much work it's going to take. So we say, okay, well, let's let the z-axis be vertical, and then we'll have planes perpendicular to the z-axis, which could be partitioned according to cylindrical or rectangular coordinates. And we're going to consider a typical volume increment that I'll call delta V ijk. Okay, ijk standing for the way you partition. You might partition R by R sub i's. You might partition J theta by theta sub j's. But we're partitioning the z's by z sub k's. So we're going to be able to say that the sample z coordinate within this small region is z sub k star. The weight of the region is constant weight density delta times your delta V ijk. And it has to be pumped to what height? Well, from here up to here is h. So from here up to here is going to be what? What's going to be h minus zk star? Of course, I pictured this as below the axis, and it's clear that if you're a certain number of units below the axis, you're going to add that number of units to h to see how far you go. And since z sub k star would be a negative number, you do that by subtracting z sub k star from h. And if you're above the axis, a little more natural to think of that, you've only got to raise it h minus z sub k. Okay? It's h minus z sub k whether it's above or below the center. Okay, so the weight is this. You got to raise it h minus z sub k star units. So the work, which is the force you have to exert to raise it, times the distance. Well, the force you got to exert to raise it is just its weight. So that the work is the weight times the distance you're raising it. So weight's going to be this. Now, whatever coordinate system you use for a typical plane perpendicular to the z-axis, is going to be the triple integral of h minus z times delta times dv. And it doesn't matter how you partition the planes perpendicular to the z-axis. Okay, it can be partitioned in rectangular coordinates x, y, in polar coordinates r theta, or in some other coordinate system. if for some reason, because of the geometry, you wanted to use some other coordinate system. So that's pretty straightforward. We want to show that that's equal to h multiplied by the total weight. Okay, so that's going to get, well, and we have to use the fact that this is the center of mass. Okay, center of mass is the origin. So how do you take this fact and get to this? Okay, well, by the same token, you can set up an integral for the center of mass in this system and compare with the integral you have here. Okay, and that's about as much of a hint as I want to give you.